How do nuclear forces create so much energy? Imagine a tiny ball of matter so powerful that splitting or merging it can produce enough energy to light up entire cities. That's what happens inside the nucleus of an atom. The core of nuclear energy lies in the strong nuclear force, which is incredibly powerful but only works over very short distances inside the nucleus. This force holds together protons and neutrons, the building blocks of atoms. When these particles are tightly bound, a lot of energy is stored in that bond. If the nucleus is split apart or fused together, that stored energy is released in a burst. Most nuclear energy comes from a process called nuclear fission. In nuclear fission, a heavy atom like uranium-235 absorbs a neutron and becomes unstable. This unstable nucleus then splits into smaller fragments, releasing a large amount of energy as heat, radiation, and more neutrons. These neutrons can then hit other uranium nuclei, causing them to split too. This creates a chain reaction that keeps going as long as conditions allow. The heat generated from this process is used to produce steam, which turns turbines to generate electricity, much like in traditional power plants but without burning fuel. The energy released in nuclear reactions actually comes from a tiny amount of the atom's mass turning into energy. According to Albert Einstein's famous equation, energy equals mass times the speed of light squared. This means that when a nucleus splits, the total mass of the pieces is a little less than the original atom. The missing mass is converted into energy, which appears as the kinetic energy of the fragments, radiation, and heat. This process makes nuclear energy incredibly efficient because a small amount of mass can produce a huge amount of energy. There is also a process called nuclear fusion, which is how the sun and stars produce energy. In fusion, light atoms like hydrogen combine from heavier atoms, releasing energy in the process. Fusion releases energy because the combined nucleus has a slightly lower mass than the sum of the original nuclei. The mass difference is again converted into energy. Scientists are working hard to harness fusion on Earth because it promises a clean, abundant source of power, but controlling fusion reactions is very challenging. From a heat transfer point of view, nuclear energy is a form of internal energy stored in the nucleus. When nuclear reactions happen, this internal energy turns into heat. That heat can then be converted into mechanical energy through turbines and finally into electrical energy. This entire process follows the basic rules of energy conservation and heat transfer, making nuclear power a very effective way to produce large amounts of electricity. So, in essence, nuclear forces create so much energy because they bind the nucleus so tightly that breaking or forming these bonds releases a tremendous amount of energy, which we can harness to power our world.